Hi everyone. Today we are going to discuss expansion of function and in which we are discuss about problem number 2 based on method of inversion. Now in the expansion of function, what are the expansions of sin x, cos x, logarithmic function, exponential function, and by using these expansion and it's a formula, you have to solve the problem second, that is based on that inversion method. Now let me start the problem number 2. Here problem is given that you have to show that log of 1 plus e to the power 2x divided by here e to the power x, that is equal to here given log 2 plus x square divided by 2 minus x raised to 4 divided by 12 plus x raised to 6 divided by 45 plus and so on. We get this series on RHS. We have to show if given is RHS. Now let me start how to solve this question. So I am starting the solution, guys. So how to solve this? So let you have to given the terms as, so I am writing here, let given as RHS. So RHS is what? I am taking the RHS. So RHS, and that is equal to, this is a log of, it is nothing but it is a 1 plus e to the power 2x upon e to the power x. This is given LHS. So we have to solve this LHS as, this is a log of e to the power x, means it's separate to denominator, guys. So it is a 1 upon e to the power x plus 1 upon e to the power x into e to the power 2x. So I am writing this in this way. So also you know that you have to also solve here 1 upon e to the power x means e to the power minus x, and plus here e to the power 2x means I am writing here e to the power x into e to the power x and divided by e to the power x. So what we'll have to getting 1 e to the power x will be get cancelled here, and remaining is only there is a log of here e to the power minus x plus e to the power x is remaining is only. So therefore after again solving this, this is a log of, I am writing for adjustment, that is e to the power minus x plus e to the power x. Now this bracket will be complete, and I am taking here dividing by 2 and multiplying by 2 on this bracket, means we have to adjustment. So there is a simple adjustment, guys, adjustment. So it will get, that is a log of 2 into, that is e to the power x plus e to the power minus x divided by 2. So clearly you know that since, or I am writing here again, that is a log of 2 into, that is a cos hyperbolic x, that is 2 into cos hyperbolic x. So what is the reason for that? So I am writing here, you know that the definition of cos hyperbolic h. So cos hyperbolic h can be written as, this is e to the power x plus e to the power minus x and divided by 2, and this is formula for cos hyperbolic x. So now let me start. Your RHS is here, clearly you have to given, let RHS is equal to, here is clearly, that is log of 2 into cos hyperbolic x, here log of 2 into cos hyperbolic x. So I am taking here the product rule of logarithm. So the product rule of logarithm says that if log is in multiplication, then you have to split in addition. Then log 2 plus log of cos hyperbolic x, log 2 plus cos hyperbolic x. So for that I am writing here again. So therefore log 2 plus log of cos hyperbolic hx, means it can be written as, you know the formula for cos of hx, guys. So I am writing these steps now as in this way. So log of cos hyperbolic hx means here this is a log of cos hyperbolic hx. I am using the series expansion of cos hyperbolic hx. So this is a log of series expansion of cos hyperbolic hx is 1 plus there will be x square divided by 2 factorial. Next one is a plus x raised to 4 upon 4 factorial plus x raised to 6 upon 6 factorial plus and so on. X raised to 6 upon 6 factorial plus and so on. You will have to getting this logarithmic series is here. Means what is the reason I am writing this step as? So let's see. The reason is very easy. So you know the expansion of cos hyperbolic hx and it is expansion is 1 plus x square divided by 2 factorial plus x raised to 4 upon 4 factorial plus and so on, guys. So that's why I am taking these steps. Now there is a small adjustment is there for simplification. We have to take bracket out of this, and we use formula for, or we use expansion for 1 plus y. That is, I am considering this term as y, guys. So we use expansion of 1 plus y. But instead of that y, first you have to assume this term as totally y. You have to assume this term as totally y and you have to expand it, guys. And we have to expand it. Now let me start the expansion. So therefore this can be written as this is a log of 2 plus this is a log of this bracket goes to assign with y. So therefore this will get 1 plus y. It's a bracket expansion, guys. So this can be written as this is I am writing now this in this way, 1 plus y directly. We use the expansion of 1 plus y directly. And what is the expansion of 1 plus y? So this can be written as this is y minus that will be y square divided by 2 plus, so I'm writing this now in this way using the expansion of directly 1 plus y. So let's see, use the expansion of log of 1 plus y, guys. And log of 1 plus y expansion is you know that is y minus y square divided by 2 plus y raised to 4 divided by 4 minus y raised to 6 divided by 6 plus and so on. In this way you have to use this expansion, guys. In this way you have to use this expansion for 1 log of 1 plus y. So this bracket is totally assigned with y, so that you have to write the expansion of this log of 1 plus that bracket. So therefore this is equal to, that is a log of 2 plus, I am writing now this bracket means y plus means y means this bracket means that is x square upon 2 factorial plus x raised to 4 upon 4 factorial plus x raised to 6 upon 6 factorial plus and so on. This is simply y minus y square divided by 2. Therefore I am writing this 1 by 2 here, and y square divided by 2 means here x square divided by 2 factorial plus x raised to 4 divided by 4 factorial plus x raised to 6 divided by 6 factorial plus and so on. This bracket is a y minus y square divided by 2 means bracket minus that 1 by 2 into this bracket square. Next term will be, what is that here, plus. Next term will be 1 divided by 4 into the bracket is also I am writing x square divided by 2 factorial plus x raised to 4 upon 4 factorial plus x raised to 6 upon 6 factorial plus and so on. Now this bracket will power is bracket raised to 4 is there, guys, and plus and so on, and plus and so on. So therefore I am taking expand up to the powers of x raised to 6, guys. I am taking expand up to powers of x raised to 6, and you have to ignore the higher powers of x, guys. So that's why therefore this is equal to, this is log 2 plus, here it will remains is here x square divided by 2 factorial. We have to expand up to x raised to 6, guys. plus x raised to 4 upon 4 factorial plus x raised to 6 upon 720, that is a 6 factorial, minus x raised to 6 upon 48. After calculating we have to getting these steps guys, plus x raised to 6 upon here 24 plus and so on. So therefore the log of 2 plus, it will take the x power as x square divided by 2 factorial plus x raised to 4 upon 4 factorial plus x raised to 6 upon here 45. You have to check guys, after calculation you will have to get this as series. So this is guys, this is LHS, this is LHS. So therefore that LHS, you have to observe what is LHS, and now you have to check what is RHS. So therefore I am writing here LHS equals to RHS. So if you have to observe this RHS is what, let's see, you have to observe the RHS, that is log 2 plus x square upon 2, right? After some calculation you will have to getting. So therefore that LHS becomes log of 2 plus here, yes, that is a log of 2 plus, now minus here also, here x power 4 upon 4, so plus minus, now then alternate sign is there, because of that this series has a plus minus sign is alternate is there. So therefore this is a log 2 plus, that is x square upon 2 factorial is nothing but 2, that minus here, so reduce here minus sign, so that's why it will take minus sign is there, that's why it will take minus sign is there, and this is what x power, that is 4 divided by here 12, x power 4 divided by 12. Next term will be plus x raised to 6 upon 45 is there, x raised to 6 upon 45 and plus and so on. Now here clearly you have to getting here LHS as a log 2 plus x square divided by 2 minus x raised to 4 upon 12 plus x raised to 6 upon 45. So I am writing the last step, that is LHS equals to, that is LHS equals to, that will get here log 2 plus x square divided by 2 minus x raised to 4 divided by 12. So clearly you will have to getting there log 2 minus that is x log 2 plus x square divided by 2, that minus x raised to 4 divided by 12 and plus x raised to 6 divided by here 45, and here the terms now as in this way, this is a plus guys, this is a plus and so on. Therefore I am writing this here now in this way, that is here minus. So you see what is LHS and RHS guys, what is LHS and RHS. So I hope you have to get the RHS as LHS. So therefore I am writing, therefore the LHS equal to the RHS guys, therefore the LHS equal to RHS means if you have to observe, that is LHS means what is that here, that is a log of 1 plus e to the power 2x divided by e to the power x, and that is nothing but this is expansion, that is a log of 2 plus x square upon 2 minus x raised to 4 upon 12 plus x raised to 6 upon 45, and hence this is proved, hence proved. I hope you have to understand this question very well, or you have to understand this problem very well. It is sufficient for today. Thank you.